So it's a bit of a sad story because no one wants to be the person bearer of bad news, and no one wants to say, actually, it's just going to get a whole lot drier. But at the same time, these are things that we need to know if we want to make plans for adaptation, if we want to help that region to develop and move out of the geopolitical mess that it's in right now. We also need to know where climate comes into it and where that's going to get into the mix. And I think it's also, in some ways, a happy story, or at least a success story, of what we can do with molecular methods. So remember the Horn of Africa, we don't have trees. It's really dry. We don't have lakes. It's really dry. We don't have really any other archives of climate change. And we were able, for the first time, to at least give a first picture of how recent climate has changed in the region. So I think that's a success for molecular methods and a success for paleoclimate, which is great. So with that, I'll say thanks, and I'd be happy to take questions.
That was a lot. That was great. Could you tie in the significant upwelling east of Sonoma? Does that make its way into the Gulf of Aden at all?
Not at our site.
Is that a completely different story?
Yeah, so at this particular site it doesn't today. If you look at the annual cycle in SST, you don't see that JJA drop that you see with the Arabian Sea. So it doesn't have upwelling this far west in the Gulf of Aden. Out towards the east, you do start to see that take over. So those dynamics are going to be different, and that's more tied to the story with the winds and the story with the monsoon winds. So the response of the winds is in many ways a completely different dynamical question, because then you're dealing with that whole large-scale circulation with the monsoon. And in fact, that's not going to affect climate that much on the Horn, because we're actually looking at those sort of interim seasons between the monsoon winds.
I guess I don't understand why they're so disconnected. I mean, areas where you have coastal upwelling, you have aridity.
Yeah.
I mean, it's all over the west.
But the aridity isn't because there's coastal upwelling in this place.
Well, okay. I mean, the southerly winds drive the upwelling.
Yeah, but
So
for example, like Namibia or Chile or Peru, those are, have coastal upwelling and they're arid, but in this case it's arid because there's no moisture coming from the Atlantic and there's mostly divergence most times of the year. And it's actually still a question as to why it is so arid, but I think it has to do with the descent of the Walker cell over there and the fact you're getting no contribution from the Atlantic. So it's not really linked to the upwelling system per se. Not in Africa. Arabia is a different story. So. Yeah.
This may be a stretch, but is there any possibility that you could find historical records that would help to calibrate rainfall? Because I'm assuming you would want a good, robust rainfall calibration, especially considering projections for the IPCC.
Yeah. So we can't really find that in the Horn. It's not there in terms of a continuous rainfall record. And I think in general, it's very difficult to calibrate sediment records to like an instrumental rainfall record. And the other thing is, technically we're looking at sort of aridity, and I use the term aridity on purpose because in fact it's really a P minus E balance. So it's not just, I'm talking about precipitation, and that's what I focus on the model, in part because the changes in evaporation are relatively small in this particular region in that model. But normally we would work at P minus E and the total or soil moisture or something like that. I think we can calibrate this proxy to that, but not temporally. I think we could do it spatially. So I'm actually working on that in the Sahara, where we have a transect of cores across a rainfall gradient. And we can look then at the change in the leaf wax composition and isotope composition and kind of form a transfer function there. So I'm able to do that elsewhere. Here, we don't really have that ability. It would be cool, and I love to do that. I think all of us want to move out of the qualitative and into the quantitative. It's just a bit challenging in this case. Yeah, good question.
So you imply that it might be a problem with the regional scale of the models, and from my perspective, it looks like it was seasonality, not regionality.
Well,
so what's the problem with the models? Do you know?
Yeah, so like the problem is they don't simulate the rainfall cycle right, and the reason that they do that I would say is probably partially because they're not capturing the microtopography. And so remember the grid resolution of these models is like 2 by 2 usually, right? So in this particular part of East Africa, the topography is enormously important. And so I think in general it rains too much in the region, and that could be because in the models they're not really blocking that Atlantic moisture like the mountains actually do. Why do they miss the long rain season though? I'm actually not sure. I don't know if they're missing it or just completely overestimating the short rains. So there's sort of two parts. I think they're overestimating the short rains because, I mean, this is speculation on my part, and I don't really have like hard evidence, but my sense is that a lot of these models kind of overdo it when it comes to ENSO. And the IOD, actually, most models simulate, it has been shown, and there is literature on this, that most models simulate the Indian Ocean dipole way too strong. So it's like, you know, and El Nino we know is generally too strong as well on a lot of these models. So if you're simulating that, every short rains, right, every time there's an El Nino in the model, it's going to dump like a ton of rain onto the East Africa, like way more than normal. And so you can see how you might build up a climatology that has really strong short rains, like too much. So that could be part of the issue, is that in our attempts to simulate ENSO, we've actually sort of amped it up in the models, you know.
So the model's tuned to ENSO to some extent, and the
Well, they're tuned to 20th century climate, and I think, but sometimes to get a regular ENSO, a realistic ENSO, you also have to have a too big ENSO. So if you look at the anomaly of ENSO in the model compared to observed, it's usually like way bigger. And so in terms of the frequency and the characteristics, you're getting a good ENSO, but if the absolute anomalies and the teleconnections, right, we don't really interrogate those, can sometimes be a little wacky. So I think, if I had to guess, I think that's the reason that the short rains are too high. I actually don't know why they're missing the long rains, though. And that's what we're working on next, is we're going to look a little more at the dynamics of the long rains. And why do some models not even have a rainy season in March through May? They should. I mean, the convergence it has to go where the sun is, so it has to eventually pass over the horn. So, like, why is it missing it? I think that's an interesting question. Yeah.
I know it's a little further away and it's closer to it's in the rift, but Turkana is pretty dry, and it's very dry. And are there lake cores from there that you are able to compare with at any level?
Turkana, there is not a good record that spans this time period. I think they don't have like a multi-core or box core, but some of the other lakes we do have records. So we have records from Victoria, Tanganyika, Lake Chala, Naivasha, Lake Malawi, and last millennium. And as I mentioned briefly, the sites that are closer to the Indian Ocean also have this sort of wet period during the Little Ice Age and then drier to present. But the interior sites are actually the opposite. They're actually quite dry during the Little Ice Age. So we see real spatial differences in the response in Central East Africa. So Turkana, to my knowledge, doesn't have a record right now that I know about. And there's also some cores, there's also some lakes in the Ethiopian highlands, but then you're dealing with a different climatology. There's a JJA rainfall, yeah.
But Turkana is not that far away, and it's very arid.
Yes.
And that was why I was thinking that it might have something of a record that might be useful, but if nobody's done it.
Yeah, I don't think they have the right core. They do have cores from Turkana that go through the Holocene and back towards the deglacial, but nothing that captures the last millennium.
Oh, it's gonna.
Okay. Is there anyone else? That's cool. Go for it.
So even in the wetter Little Ice Age, is there any geological evidence of that humidity, of braided streams, anything like that, any discharge? Your core didn't show anything, I guess. Well, it didn't go back to the Little Ice Age. Yeah, it did. And so you said it's wetter.
Yeah.
Okay. So in arid regions that become wetter, you crank up braided streams. Those braided streams have to go somewhere.
Well, I don't think there's any braided stream evidence, but the lake level, we have lake level records,
Okay.
you know, from central equatorial Africa, like I mentioned, and they show high stand at the time.
Nothing made it into the Gulf of Aden during the ice age.
Not that we, I mean, there aren't any, I mean, it was wetter, but I don't know, like, it wasn't necessarily like, you know, like Florida, right? I mean, it's probably just a little bit wetter.
You know, what goes on in the western part of the United States when it gets wet, you get flash flood.
Yeah, I mean, the problem is you can't go do field work, right?
You can't what?
You can't exactly like go tromping around in Somalia looking for braided streams. I mean, you could try. I'll let, why don't you give it a shot, you know?
I was thinking of your core, I mean, so,
Why would my core record braided streams?
because just offshore, if the braided stream's discharging, you know.
No,
well,
there's no real drainage. I mean, there's like tiny drainage bays, but it's far enough offshore that it's not in a delta or anything.
I mean, that's what I'm getting at, it's wetter, but it's still there.
No, I mean, it's, yeah.
How about dust, changes in dust delivery?
Yeah, I mean, you can look at the coarse fraction and look at that. I mean, you know, we can look at the concentration of leaf waxes. Doesn't actually change very much, so we figure that the delivery of the terrestrial organic matter has been pretty constant. We do have folks who are working on dust reconstruction for the Holocene, where we see, of course, the humid period big changes. I don't really know to the extent that you can pick up these smaller changes with, for example, uranium, thorium, and stuff like that.
Your
So-
colleague Peter Domenico did that west side.
Yeah, but the Holocene, like, that's a big change. So obviously in the Green Sahara, there's just orders of magnitude change in dust delivery. So that was what I was just saying, is that I don't know, we are working on that, but in the longer record, I don't know if it's possible to do that on these times. It would be cool if it was, though.
I think we're gonna have to
You can ask later.
call it, but yeah, you can stick around. I'm sure Jeff will be willing to entertain.
Yeah.
All right, thank you all for.
Thanks.